Welcome back. This is question 2 on the N25 mock paper 3. This question can be solved without a calculator. So let's start with part A. This is a very straightforward result that you have seen in the course. We are going to use the compound angle formula for 3 alpha. If you struggle with the previous part, with part D of question 1, please never forget that each question is a new start. And you can always redeem yourself in air quotes in the following question. Never ever leave any question blank. Part A is a show that question. So you must show every single step to get full marks. Part B. Now we'll consider triangle ABC with 3 angles. And we are asked to show that this result is true. We already have angles alpha and beta. So let's go ahead and apply the sine rule to get the length of AB. We know that angle ACB is equal to 180 minus 3 alpha, or pi minus 3 alpha radians. So if we want to use the sine rule, we'll have AB divided by sine pi minus 3 alpha is equal to BC divided by sine alpha. And therefore, AB is equal to x sine of pi minus 3 alpha divided by sine alpha. Sine of pi minus x is equal to sine of x because of symmetry of the cosine curve. It is symmetrical about the line x equals to pi by 2. Sine alpha cannot be equal to 0. And this is because alpha is not equal to 0, and alpha must not be equal to 180. Because we know that 3 alpha plus angle ACB has to be equal to pi radians. Therefore, we can simplify the sine alphas, and we will have arrived at our destination. Part C. D is the midpoint of A, B. E is the foot of perpendicular from C to AB. We want to find the length of CE. To find the length of DE, we need to find the length of EB. So, the idea is noticing DE is DB minus BE. DB, we know it to be a half of AB because we know D is the midpoint of AB. AB is equal to this expression over here. So a half of AB, that's a half of x times 3 minus 4 sine squared. BE is equal to x times cos of 2 alpha. Let's expand and simplify to see if we can simplify anything. We want to get rid of alpha. So the most rational expression we can use is 1 minus 2 sine squared alpha. That wouldn't work. What would work? Oh, there should be a minus sign. So now the 2x sine squared alpha will cancel out, and you're down with this guy, or x divided by 2. Very convenient. F lies on the perpendicular bisector of AB, and is a distance x from C, as we can see. Points F and B lie on the same side of the line through A and C. We want to show that FC trisects angle ACB. So we showed earlier that this big angle is pi minus 3 alpha, and our job is to show that this smaller angle over here is pi by 3 minus alpha. So how can we achieve that? First off, notice that CGDE is a rectangle. And the reason is that it has 3 right angles. Usually this explanation will be optional, but considering the number of marks associated with this part of the question and its relative length, I would suggest showing all your work and explanations. Because this is a rectangle, we can deduce that CG is equal to DE. We know that this big angle, we know that CF is equal to X. So that gives us a very useful piece of information. Angle GCD is therefore arc cos of CG divided by CF, or arc cos of 1 by 2. And this angle is 60 degrees. What else do we know? This is actually very convenient because all you have to do is just noticing that since GC and AD are parallel, which is yet another consequence of this being a rectangle, this means that angle JC angle GCA is equal to angle CAD and is equal to alpha, as they are alternate angles on parallel lines. Thus, the angle we are looking for, ACD, is simply pi by 3 minus is equal to JCD minus GCA, and that's gonna be pi by 3 minus alpha. And this is exactly 1/3 of alpha minus, of pi minus alpha. Thus, FC trisects angle ACB. This is the end of the question.